Hello students, welcome back. So basically in this video, students, we are going to focus more on solving the numericals of chapter number 5, which is nothing but upthrust and Archimedes principle. Now, when I do talk about upthrust, guys, let's have a quick recap like what is upthrust. In our chapter number 4, we learned that what is pressure. Pressure is nothing but thrust upon area. And that thrust is something which is going to act in vertical downward direction. Same way, when I do talk about up thrust, the word says up thrust. The thrust which is going to act vertically upwards is going to be called as up thrust. This up thrust which is going to be created or this up thrust which is going to be seen will be because of fluids. Fluids basically means it would be liquid or it could be a gas. Okay. So today, guys, we are going to solve some numericals which are based on the type A of this chapter, which are related to calculation of upthrust, which are even related to calculation of apparent weight, and which are even related to loss in the weight or loss in the volume of an object. So let's try to solve that questions. The questions which I am going to solve, they are from our textbook. So here are certain questions which we do have. But students, before solving the questions, we will first try to make a list of the formulas so that it should become easy to understand what are the different formulas which we need to focus on and how are we going to solve them. Okay, so let's try to make a list of the formula guys first, and then we will try to go ahead with the solving part. So when I do talk about the list of the formulas, the very first formula which we need to focus here is on calculation of FB. So for those students, those who don't know FB, FB is a short form for upthrust. And this FB is calculated by using the formula called V rho G, where guys, V represents the volume of the solid which is immersed in that liquid. Okay. Rho represents density of liquid. Guys, it is density of liquid, huh? It is not density of solid. G represents acceleration due to gravity. Okay. If G is not given to me in the question, you will write it as it is. If your mass or if your volume is in CGS unit, then you will write it as GF. If your volume and mass is in SI unit, then you will write it in terms of KGS. Okay. You will come to know, guys, how to solve this thing when we will try to solve some more questions on this. The second formula, guys, which we do have after FB is the loss in weight of an object. So loss of weight of an object is calculated by either subtracting weight of the object in air minus weight of the object in water, or it can be calculated, students, by weight of the object in air minus the upthrust which is acting on the object. So there are basically two different formulas which we can try to use it. Loss in weight can be even called as an apparent weight. Okay, so these are different terms which they can try to give you so that you get manipulated, but we need to be very focused when we are going to solve the sums. Okay, guys. The third, the most important part, which is related to this part, is whenever they say that the object is floating. Okay, so if the object is in a state of flotation, or if the object is floating, guys, the weight of the object, listen carefully, students, the weight of the object or the FB which is going to act on the object will be equal to its mass. Means, for example, they say that there is a hollow wooden block which is dipped in the water. Now, since it is hollow wooden block, can I say that wooden block will float, students, because it is hollow? Now, since it is going to float, FB ka value for that wooden block will be the mass of the block which is given to us. Let us say that they have given me the mass of the block as 5 kg. So upthrust at that moment of time will be 5 kgf. If FB ka value, students, I need to find out for any object who is going to float, it should be equal to its mass. Okay. Taking these things into consideration, guys, let's try to go with the question number one. The question number one says that a body of volume 100 centimeter cube. So we will have to write the volume which is given to us. So let's try to write here question one. So they have given me the volume which is V is equal to 100 centimeter cube. Then guys, they have instructed its weight in air is 5 kgf. So weight in air is given to me. So we will write here W air. That is 5 kgf. Is emerged in a liquid of density. So they have given me the density of liquid, which is 1.8 into 10 raised to 3 kg per meter cube. Guys, now when I'm solving this sum, I don't want you all to sit idly in front of the screen. I even want you all to solve with me. Okay. These are certain values which are given to us, guys. We need to find out total here two things. First, as you can see in the question, we need to find out what is the upthrust. Second, we need to calculate what is the weight of the body. So to calculate upthrust, students, we will try to use a basic formula. The formula is FV is equal to V rho G. V represents volume of solid. Now here, volume of solid is given to you in centimeter. If you see the other values, they are in SI. This is in CGS. So centimeter ko we will convert it into meter by dividing it by 100. But since this is centimeter cube, you will divide it by 3 times. As it is centimeter cube, 0 gets cancelled. So you will get your value as 1 upon 1, 2, 3, 4 meter cube. This is the volume. So we will try to substitute. So we get FB is equal to V, which is 1 upon 1, 2, 3, 4 into density of liquid 1.8 into 1, 2, 3 multiplied by G. You try to cancel it out, guys. 1, 2, 3, 1, 2, 3. You are left out with 1.8 upon 10, which is 0.18 kgf. I am writing it. Sir, why did you wrote kgf, guys? Because everything is in SI, you know. Okay. So this is the upthrust which I calculated. Second, students, they need to find out what is the weight of the object in the liquid. So when I try to dip this object in the liquid, we know that it will feel lighter, right? Why does it feels lighter? Because there is upthrust which is pushing that object upwards. Okay, so its original weight is trying to act downwards, guys. At the same time, FB is trying to push it upwards. So its original weight is 5 kgf. FB, which is going to push it vertically upwards, is 0.1. So when you subtract both of them, can I say you will get the weight in liquid? So that is weight in air minus the FB, guys, which is 5 minus 0.18. Okay, so when we will try to subtract this, students, we will get our answer as 4.82 kgf. This is my question number one. I hope I have made myself very clear, students. The questions are much more easier. Like you don't have to stress more on formulas and all that thing. You need to stress more on understanding the concept. Okay. Chalo, let us take the second question, students. Second question is a similar category of question. Let us first try to write what data they have given us. So students, they have instructed a body of weight 450 GF in air and 350 GF in water. So let us try to write it. So they have instructed, second question, weight of the body in air, and they have given me weight of the body in water. So when I try to write weight of the body in air is 350 GF, then they have given weight of the body in water, which is 310 GF. I am supposed to find out three things there. First, I am supposed to find out what is the volume of the body. Hey, I think this so you all know this thing, how to solve. Volume of a body can be calculated by weight in air minus the weight in water. So students, weight in air is 450. Weight in water is 310. When I try to subtract this, I will be getting my answer as 140. But since guys, I am talking about volume, volume is never measured in GF or kgf. Since it is volume of a body, which is a solid, so I will write it as centimeter cube. If this was given to me in kgf, guys, then I would have written my volume in meter cube. Okay. I hope we are able to understand the logic and the scenario which I am trying to talk. Great. After A part, then comes B part. B part may they have instructed what is the loss in weight of the body. Acha. So loss in weight. I think loss in weight, so we all know how to solve the loss in weight, guys. For calculating the loss in weight, I will straight away write here loss of weight means how much is the difference in weight. Loss in weight is basically equal to weight in air minus weight in water, which would be the same 140. Now, since I'm talking about weight, this is 140 GF. Weight is measured in GF or kgf. The C part, guys. C part is I am supposed to find out what is the upthrust acting. So when I'm talking about upthrust, upthrust is FB, which is V rho G. Here, volume of solid is given to me, guys, which is 140. Density of liquid, which is water, I will take it as 1. G ka value is not given, so I'm putting it as it is. So I'm getting my answer as 140 GF. This is one trick to solve. Another trick to solve is upthrust can be even written as weight in air minus weight in water. Subtract here, we will get the same to same thing. Okay, students, I hope we are now confident in solving this sums. Let's try the next one. Come on, let's try question number 3. You just need good amount of practice so that we are able to crack this question well. Okay, question number 3 is you are provided with a hollow iron ball A of mass 15 centimeter cube and 12 grams and a solid ball of mass 12 grams. So there are two instructions which are given to us. I'll try to write it so that there is no confusion. There are two different types of balls here with me. First one is the iron ball, which is hollow, and the second one who is solid. So I'll write over here hollow iron ball. The second one is solid iron ball. So it is solid iron ball. What all things they have instructed? They have instructed for hollow iron ball, the volume is 15 centimeter cube, guys, and mass is 12 grams. This is given in the question. For solid, they have given us mass, which is 12 grams. They have not given us volume. They both are placed in water. So the liquid which I do have, in which they are going to be placed, is water. Okay. I am supposed to find out first what is the upthrust acting on the object. This is simple. To calculate upthrust, I will try to find out upthrust in both the cases separately so that it becomes easier. I know the formula for calculating upthrust. Upthrust ka formula is V rho G. Now, since I am talking about hollow iron ball, I think, guys, it is going to float. If you remember, we had learned that technique. Whenever an object is going to float, its FB is equal to its weight or it is equal to its mass. The problem is this. Here, many students will try to use the formula FB is equal to V rho G and they will get an incorrect answer. So, students, for this case, we will write FB is equal to mass of that object, and the mass of the object is already given to me, which is 12 grams. So, I'll try to substitute. I will get over here 12 GF as FB of the object, which is going to float. Now comes the second part. We need to calculate FB for the iron ball also. Now for calculating FB, I need mass of the object, which is given to me. I need the density of the object, density of the liquid in which it is immersed. So the liquid which I do have is water. Density of water, students, I will take it as 1 GCM raised to minus 3. Why did I took GCM? Because mass is given in gram. If it was given to me in kg, then I would have taken it as 1000. Okay, guys. So we will write over here FB is equal to V rho g. Here V represents the volume of the object. Guys, have they given us volume of the object in this case? I don't think so. They have given us, right? So we will have to first calculate what is the volume of that object. So to calculate the volume of the object, what formula should we prefer, guys? Perfect. We know that density is equal to mass upon volume. If I notice my question carefully, they have given me density of iron, which is 8 GCM raised to minus 3. Now, density is 8, mass is 12, so volume will become 12 upon 8 centimeter cube. I will instruct you all to keep it as it is. Don't convert it into decimal because this I don't need as my final answer. I am going to substitute it ahead. Now, students, we got everything. So we know that FB, which is equal to V rho G. V is volume of the solid, which is 12 upon 8. Density of liquid, I know it is 1, and G is as it is. When we try to solve this thing, it will go with 4 ka table. 4 threes are, 2s are. 3 upon 2 will give me 1.5. So my answer is 1.5 GF. This is the buoyant force which is going to act for iron ball, which is solid. And the iron ball who will experience an upthrust will be 12 GF. Easy, guys? Simple? Sure. Let's go with the next part. The part B says that which of the object will sink and who will float. It's very simple and it's very obvious. If I do talk about floating and sinking, definitely the solid ball will sink. Why the solid one will sink? Because its FB is less as compared to the weight of the solid. You can see for solid, the FB is only 1.5 students, right? And for hollow, the FB is 12. Okay. I hope that logic and concept we already know it, right, students? Come on. Let's take the fourth one, students. Question number 4. Again, let's try to read it out and let's try to figure out how to solve this question 4. So, fourth one. Question 4th, I want you also to help me out. Okay. So, fourth one is a solid of density. So, density of solid is given. Weights 0.5 kgf in air. It is completely immersed in water of density 1000. Calculate the apparent weight. Apparent weight means weight in water. So by default, we need to first go with the given part. So let's try to write what all things are given to us. See, if you find it little bit challenging to solve, I would suggest you all to keep your textbook in front of you guys and then solve so that you have your question also with you. I will make a note. They have instructed density of solid is 5000 kg per meter cube. Its weight in air is given to me, which is 0.5 kgf. It is completely immersed in liquid of density 1000. So density of liquid or density of water is 1000 kg per meter cube. Find out what is the apparent weight. Apparent weight means the fake weight. That is weight in liquid is supposed to be found out. I will use my formula to calculate this thing. So first of all, to calculate weight in liquid, I need to calculate FB. So we know that FB is equal to V rho G. Here, I need to know what is the volume of solid. So the problem is they have not given us the volume. But students, the good part is they have given me density of solid. So I will write here density is equal to mass upon volume. This I am calculating it for solid, students. See, density of solid is given to me 5000. Weight is given to me 0.5 kgf. So from weight, students, can I write this is my mass? You remove GF, you get your mass. So you will get mass as 0.5. Volume we don't know. So we will write here V is 0.5 upon 5000 meter cube. This is my volume. Now I try to substitute in my FB ka formula, which is FB is equal to 0.5 upon 5,000. Density of liquid is given to us, which is 1,000, and G as it is. I think three zeros will get cancelled, guys. On cancelling the zeros, I will get FB is equal to 0.5 GF. I hope this is clear to us, guys. Any confusion, any doubt here? Everybody? Great. So I got my FB. After getting this FB, guys, we are supposed to find out its weight in liquid. To calculate weight in liquid, we will use the formula, which says that weight in liquid is equal to weight of the object in air minus the FB, which is acting. Weight of the object in air is 0.5. And FB, we need to use it. So here FB is 0.5 upon 5, which will be 0.1 GF, guys. So here this will be 0.1. That will be 0.4 GF. That is weight of the object in liquid. Okay, makes sense. I hope this is clear to all of us. Sure. Come on, let's take the next question, students. This was question number 4. Here comes question number 5. So fourth के बाद fifth question goes in this particular manner. Fifth is a very nice question. So focus and understand. Question fifth is two sphere A and B, each of volume 100 centimeter cube, are placed on water. The sphere A has density of 0.3, which is made up of wood, and sphere B is made up of iron. We need to find out certain things here. The certain things, let's first try to write it so that you understand what all things are required and what all things are given. So I'll make a table for you all, which gives a better idea. There are two spheres, students. One is A and second is sphere B. They have instructed both the spheres each of volume 100 centimeter cube. So volume of the sphere is given to me. 100 centimeter cube. This is also 100 centimeter cube. The sphere A is made up of wood. So the first one is made up of wood. So we need to write here. This is made up of iron. Wood ka density is 0.3. Definitely it will be less. Iron ka density is 8.9 GCM raised to minus 3. Got it? We need to find out, students, what is the weight of each of the sphere. Now to calculate weight, I technically need mass because I know that weight is equal to m into g. Now to calculate mass, I will have to take the help of this both the values. Why? Because students, we know that density is mass upon volume. So let's try to find out for the first one. So for the sphere 1, if I try to calculate, I will use this formula. Density is mass upon volume. So students, density for the first sphere is 0.3. Mass is not given. Volume is 100. This goes over there. So you will get 30 G as the mass, 30 grams. So weight of the first object will be 30 into G, which will be 30 GF. ये हो गया first object का weight. Then comes second object का weight. So we have W is equal to M into G. Here also we will go with that same part. I know that density is mass upon volume, guys. The mass is given to me. No, the mass is not given. Density is given to me precisely. So density is 8.9. So we write here 8.9 upon volume is 100. This gets cross multiplied. So we get 889 will be the mass. 89 grams is your mass. Got it, guys? Now, if 89 is your mass, I try to calculate its value by simply using the formula. The formula will be mgh. Wait a minute. I think I have made an error in the calculation. This is, yeah, this will be 89 upon 10 multiplied by 100 is equal to m. The zero gets cancelled. So you will get m ka value as 890 grams. When I supposed to calculate weight, students, it will be 890 into g, which is 890 gf. This is the weight which we have found out. That's my first part. Second part, students, which we need to find out is after calculating weight is what is the upthrust on both of them. So first case ka upthrust will be equal to weight. Reason because this is hollow. The hollow guy will float. As it is going to float, its FB will be equal to its weight, which is 30 GF. Second case mein, if you need to find out FB, we will have to use V rho G. I think volume they have given to me for solid, which is 100. Density of liquid, I'm taking it as 1, which will be multiplied by the G. So here FB will be 100 GF. Is it clear, guys? Okay. So here FB is 100 GF for the second case. They have instructed which of them will float and which of them will sink. What do you feel, guys? Who will float and who will sink? Chalo, you think and you let me know. Sphere A will float or sphere B will float? That's correct. Reason why sphere A will float, guys, because it will experience more FB, right? So we will straight away write here the weight, look at the weight and look at the upthrust which is given to us. So when we try to see the weight and when we try to see the upthrust, I can simply say that that object will float easily. Okay. So sphere A will float because it is hollow. Okay. Clear? I hope this question is clear and we all are writing it properly. Let us take the other question, students. So this were the first 5 questions of our exercise. Now here comes the next 5 questions. So when I do talk about the next 5 questions, they are almost similar. The good part is they are basically based on more part related to formulas. Like let's try to solve so that you get a better idea, guys. Question number 6. So the sixth question simply instructs us that what should be the weight? Just a minute, guys. The question number 6 is, yeah. So sixth question is the mass of the block made up of certain material is 13.5 kg and its volume is 15 into 10 raised to minus 3. So we do have here mass given to us for the sixth one. So they have instructed the mass and they have given us the volume. So the mass of the block which is given to us students is 13.5 kg and volume of that block is given to me as 15 into 10 raised to 3, 10 raised to minus 3 meter cube. This is the volume which is given to us in the question. We need to calculate FB. I think this is simple, guys. We know the formula. FB is equal to V into rho into G. Okay. Since they have instructed that this is dipped inside the water. Now, density of water, if it is not given to you, you have to do certain assumption. Since your mass is in kg, you will take density of water as 1000 kg per meter cube. This though we already know, right? So when I try to substitute, I will be getting volume of the solid, which is 15 into 10 raised to minus 3 multiplied by 10 raised to 3 density of water into G. 10 raised to 3 minus 3 will get cancelled. You will get your FB as 15 kg Fs. After getting FB ka value, you know what is the next part, students, we need to find? We need to find out, will this block float or sink in water? Okay. So for B part, I'm supposed to find, will it float or will it sink? I think its mass is given to me. The mass of the block is 13.5 kg. So can I say, students, its weight will become 13.5 kgf? On this weight, guys, there is FB of 15 kgf acting. So can I say buoyant force is greater than the weight of the object, which means the object will float. Okay, the C part. The C part is, what will be the buoyant force? What will be the upthrust on the block when it is floating? Okay, this is so nice. They have already instructed it is floating. And guys, we know that whenever an object floats, its FB is equal to its weight of the object. So यहाँ पे we will write FB is equal to 13.5 kgf when it is going to float. I hope I have made myself very clear, students. Seventh question. Come on. The question number 7 is like this. A piece of brass weighs 175 kgf in air and 150 when it is immersed in water. So I will write here weight in air 175 gf, weight in water is given to me, and the weight in water given to us is 150. Then students, they are updating us that it is immersed in a liquid, and that liquid is water, whose density given to us is 1 gcm raised to minus 3. We are supposed to find out first what is the volume of the piece of the brass. So volume of object I'm supposed to find. Yeah, I think this is simple, guys. Now we are expert in this thing. Volume will be equal to weight in air minus weight in water. 175 minus 150, which will be equal to 25 centimeter cube. Am I right, guys? So we will write here volume as 25 centimeter cube. Then comes the next part. Why does the brass piece weighs less in water? Why does the brass piece weighs less in water? Can I say it weighs less? Its weight is less. Reason because FB is acting upwards. Since FB is acting upwards, its weight is going to be less. Is it clear? Is it simple, students? Come on, let's take question number 8. Question number 8, I think majorly many students had a doubt. So let me try to solve and explain you the eighth question. So question 8 is a weight of cube of edge 5 centimeter. So edge means side is given to us. So I'll write here over here side of the cube is 5 centimeter. Then they have instructed the density of that cube is also given to us. So density of solid is 9 GCM raised to minus 3. It is suspended through a thread and it is completely immersed in a liquid. So density of liquid is given to us 1.2 GCM raised to minus 3. They have instructed take value of G as 10 meter per second square. We need to find out one simple thing, and that one simple thing is tension in the thread. Now for those guys who are not able to figure out what does this tension means, suppose if this is an object, rigid support, which is suspended through a string, and if this is the object whose weight is acting vertically downwards, in order to balance that weight, there will be a tension force which is applied upwards. To calculate that tension force, guys, you need to find out the weight of the object in air, subtracted by the FB, you get your answer. Okay, so I will help you out how to solve this thing with the given updates. They have given me side of the cube. So from that side, I can calculate volume. It is cube. तो cube का volume होता है side into side into side, which is 125 centimeter cube, guys. Okay. Since I'm supposed to find out the weight in air, I need to first know mass. So I will find out over here weight in air. Weight in air is equal to mg. M I don't know. So to calculate M, I will use the formula density is equal to mass upon volume. Density of solid is given to me 9. Mass I am supposed to find and volume I found out 125. So students, I can say mass is equal to 125 multiplied by 9. When I try to multiply, I will be getting my answer as 1125 grams. That is the mass of the object. I substitute here, so I will get weight in air is equal to 1125 GF. This is the weight which I found out in air, students. Now let's find out FB. So FB is equal to V rho G. Volume of the solid, we found out 125. Density of liquid is 1.2 multiplied by G. Guys, here it is not water, huh? So please don't take 1. When we multiply this thing, we will get 150 GF. This is the FB. So tension in the string can be found out by subtracting the weight of the object in air minus FB, which will be 1125 minus 150 GF, which would give me the answer as 9.75 GF. Okay, students, is it simple? Is it clear? Great. Now, if I want to convert it into Newton, then I will straight away write it as in terms of Newton also. I hope this question is clear. Great. Similar way, guys, we have question number 9 and question number 10. I want you all to try this question 9 and 10 and do let me know if you have any doubts or any difficulties. The questions are almost the same. In ninth one, you just have to find FB. They have given you volume, density of water you will take, and you will substitute G ka value and you will get your answer. Same way, students, question number 10 is done. Question number 10 is similar to that of question number 2, which we have done. Okay, so these were the questions of type A, guys. Practice them well so that you guys are confident. Similarly, I will also share a video on type 2 so that your things are getting cleared and the concepts are going very well. Okay. Till then, everybody, guys, practice well, solve the sums. There are some good solved examples also. So when you will try to solve that solved examples, you will be, guys, in a better position to understand how to solve and how to clear out these concepts. Okay. Bye bye, everybody. Take care. Have a nice and amazing day.